Hello everyone. Today we are going to solve trim a binary search tree problem. It is very interesting problem. You can see by the number of votes and devotes. So we are given with the root of a binary search tree, and we have to and the lowest and highest boundaries, and we have to trim all the elements which are not in the range of lows and highs. So trimming the tree should not change the structure of the trees. That means if an element is in the left side, so it should be in the left side, or if it is on the right side, then it should be on the right side. So that means we have a unique answer. So we have to return our trimmed binary search tree node. Okay. So let's understand with an example. So here in this example, this is our BST, and in this BST, 0 is not in the range of 1 and 2. So we just trim it, and there is no other element which are not in the range. So we are going to return this. So this is our answer. This can't be our answer. Okay. So we have to follow the same structure. So yeah, this is the only answer of this question. So let's so how we are going to solve this problem. Okay, so let's see with this example. So in this we have given a 3 0 4 2 1. Okay, and our range is low equals to 1 and high is 3. As we know that in the BST, if it is a 3, that means all the element in the left side would be less than 3, and all the elements in the right side would be greater than 3. So just keep this point in our mind and let's solve this problem. So we are going to check if this 3 is less than low or not. If it is less than low, that means all the element here on the left side are also less than low. That means all the element in the left side will not be in our answer. So we are not going to see this. Okay, if it is so. But right now, the 3 is less than 1. No. So our answer will be there. Okay, it will be there. So let's see if our root value is greater than high. Is it greater than high? 3 is greater than? No. That means our answer can be there also. Okay, so we are going to check in the both side and see the trimmed answer of here and trimmed binary search tree here, and we'll join something like this. So our answer would be something like there will be BST and there will be BST. Our answer would be like this. So now let's see. We comes to here. First see this left side. So here is 0 is less than 1. Yes. That means 0 is less than 1 means that all the element in the left side will not be the answer of our trimmed binary search tree. So we are going to see in the this here right side. So we are returning this answer. We are returning this answer. Okay. So now let's move here. Going to check on this. So here is 2 is less than 1. No. 2 is greater than 3. No. So we are going to check its right and left both part. So first of all, let's check with the 1. So 1 is less than 1. 1 is less than 1. No. And 1 is greater than 1 is less than 1. So this is not true. 1 is, so we are going to see both sides. So here we are going to see both sides, and we find both of this element are null. So we are going to return this one. Okay, this one, and now this left side is done. So we are going to return it 1. So our answer would be like 1 returning to 2. Okay, so let's see our right side. So in the right side it's null, so we are going to return null. So our tree is like 2 pointing to 1. This is, so now this returns to here, and because this is trimmed, so we are going to return this. So this will be the in the left side. So this would be our left side answer. So let's check our right side. So in the right side, our 4 is greater than 3. That means all the answer in the left side will be our answer. So left side is null. So we are going to, here is null. That means there is nothing. So our answer will be 3 2 1. So this is our answer. So I hope you understand the intuition. So let's see the code and have a try run there also. So this is our solution. So if a root is null, then we are going to return null. If its value is lower than low, That means we are not going to see its left subtree. We are interested in the right subtree only. If it is value is higher than high, that means we are not interested in the right subtree. We only need left subtree. Otherwise, if this is not the case, the root value is in the range of lower hand, that means we have our answer in the low, in the left side as well, in the right side as well, and we have to see both answer, and we are going to return like this is our root and there will be our left and right both. So let's have a dry run. So right now let's use the previous example only. So this is our 2 1 and this is. So first of all, what we are going to do is we are going to call our function, which is root is, let me denote it by 3 1 and this is 3. Okay, this is high, this is low. So we are going to call this function, and once we call this, we are going to check is it null. No, it is 3, it's not a null. Okay, and then we are going to check is the root value is less than low. So is 3 less than low, 3 less than 1? No. So not going to this condition. Is 3 greater than 3? No, we are not going to this condition. So we are going here root left is equals to this. So we are going to root left, this is our left. Okay, you can denote it by root left equals to t of what it is left, and left is 0 1 3. So we are going here, so we call this function. So now we are starting check, is it null? No. Is it value less than 1? Yes, absolutely. So its value is less than 1. So we are going to calculate its right value. Okay, we are going to check its right value. So we are going to calling this 213, and so in the 213 is 2 is less than low? No. Less than greater than high? No. So we are going to call its left. So we are again going to call its left, and left will be 1 1 3. So 1 is less than low, 1 is greater than no, both of the cases no. So we are going to call its left. So first of all, we are going to call its left. Okay, so in the left we have its null. So it's going to return null. Okay, it's going to return null, and its right will also going to return null. In both of case they are going to return null. So we are going to return this root. So right now we have this of this two function call is remove, and our subtree is like we are returning 1. We are returning 1. Okay, where? To the left of this. Okay, so this is done, and we are going to return 1 here to this. So now move to the right side of this. So right side of 2 is null, so it is returning nothing. So right side is null and left side is 1. So we are going to return 2. So now we are going to returning 2 here. Okay, 2 is done. Now we are our so here we just return right. Okay, here we just return right, so we are not checking right. So this will return right only, right side of subtree. So this is done, and this return right side only. Right side to which? This is returning right side only. So this is our root right now. Okay, we are here, and now we are going to call the right side. That means we are going to call 3 4 1 3. So 4 is greater than 4 is less than 1 low? No. 4 is greater than high? Yes. So we are going to call its left. Left is, it is null. Okay, it is null. So it's gonna return null, and so here it's returning null, and null is returning to 3. So here null is returning, that means null is returning to 3. So our answer would be 3 2 1, and here is null. Okay, so this is our answer. I hope you understand this solution. If you have any doubt, or if you understand this, so you can ping me in the comment section, and you can check the source code in the description. Or thanks for watching.